Bismillahirrahmanirrahim. My name is Dr. Ayaz Afsar, and our topic today is using tests as a research tool. Since the spelling test of Rice 1897, the fatigue test of Ebbinghaus, that was in 1897, and the intelligence scale of Bennett 1905, the growth of tests has proceeded at an extraordinary pace in terms of volume, variety, scope, and sophistication, and they have been used as a research technique, as a data collection tool in number of studies. The field of testing is so extensive that the comments that follow must needs to be just an introductory nature, and the reader seeking a deeper understanding will have to refer to specialist texts and sources on the subject of testing. Limitations of space permit no more than just a brief outline of a small number of key issues to do with tests and testing. In tests, researchers have at their disposal a powerful method of data collection, an impressive array of tests for gathering data of a numerical type rather than a verbal kind. Means that would be more qualitative, more quantitative rather than the qualitative one. In considering testing for gathering data for research, several issues need to be borne in mind, not the least of which is why tests are being used at all. A number of issues include some of these. What are we testing? For example, achievement, aptitude, attitude, personality, intelligence, or social adjustment. Any of these topics can be tested. Second point, are we dealing with parametric or non-parametric tests? The two main categories will be explained later on, that whether we are dealing with a parametric or non-parametric test. Number three, are the norm referenced or criterion referenced tests we are dealing with? The two major categories will be explained later in the session. That will be about what is a norm referenced or a criterion referenced test. Number four, are they available? Are the tests available commercially for researchers to use, or will researchers have to develop home-produced tests? And number four, do the test scores derive from a pre-test and post-test in the experimental method? If it is a kind of experimental research, so whether it would be a pre-test and post-test, and those scores would be matched, and how should they be similar or different? Number five, are they group or individual tests? Some tests can be given in groups, others are only given to the individuals, and what's the difference between them? Number six, do they involve self-reporting? Are they administered tests? So can the test be given to the individuals to do their own pace and time, or they would be administered in a controlled situations? So let's unpack some of these issues in more detail. First of all, let's begin with what are we testing? Point number one. There is a myriad of tests to cover all aspects of a student's life and for all ages, young children to old adults. For example, we have the tests on aptitude, attainment, personality, social adjustment, attitudes and values, stress and burnout, performance, projective tests, potential tests, ability tests, achievement tests, diagnosis of difficulties tests, intelligence tests, verbal and non-verbal tests, verbal and non-verbal reasoning, higher order thinking, performance in school subjects, introversion and extraversion, self-esteem, locus of control, depression and anxiety, reading readiness, university entrance test, interest inventories, language proficiency tests, motivation and interest, sensory and perceptual tests, special abilities and disabilities, and many other types of tests. So we can test any of, or even the list is not exhaustive, more areas where tests can be used and where the areas can be tested. The second point about the types of tests would be parametric and non-parametric tests, and I am going to explain these two terms in a while. Well, parametric tests are designed to represent the wider population. For example, of a country, the whole country, or a particular age group. They make assumptions. The parametric tests make assumptions about the wider population and the characteristics of that wider population. That is, the parameters of abilities are known, and they assume the following, and they have been recorded by Morrison 1993. There is a normal curve of distribution of scores in the population. The bell-shaped symmetry of the Gaussian curve of distribution seen. For example, in standardized scores of IQ, or the measurement of people's height, or the distribution of achievement on reading tests in the population as a whole, maybe the population of the whole country. There are continuous and equal intervals between the test scores and with tests that have a true zero. The opportunity for a score of, say, 80% to be double that of 80%, 40%, means the person who scores 40% is less able, half of the ability, than the person who scores 80%. This differs from the ordinal scaling of rating scales discussed earlier with questionnaire design, where equal intervals between each score could not be assumed. A little more about the parametric tests. Parametric tests will usually be published tests which are commercially available and which have been piloted and standardized on a large and representative sample of the whole population. They usually arrive complete with the backup data on sampling, reliability, and validity statistics which have been computed in the devising of the tests. So working with these tests enables the researcher to use statistics applicable to interval and ratio levels of data, examples of which of these interval and ratio levels we have discussed. We already discussed with reference to questionnaires, interviews, and observations. Now move on to the other kind of the tests, those tests which are non-parametric tests. So non-parametric tests make few or no assumptions about the distribution of the population. The parameters of the scores are the characteristics of that population. They don't represent the whole country or the entire population. Non-parametric tests do not assume a regular bell-shaped curve of distribution in the wider population. Indeed, the wider population is perhaps irrelevant, as these tests are designed for a given specific population. For example, a class in a school, a chemistry group, a primary school year group. So they are very specific to a particular group. Because they make no assumptions about the wider population, the researcher must work with non-parametric statistics appropriate to nominal and ordinal level of data. Parametric tests with a true zero and marks awarded are the stock in trade of classroom teachers. Means most of the teachers use these types of tests in their classrooms, and they are suitable for academic purposes. And such type of tests in the classroom, like the spelling test, the mathematics test, the end of year examination test, or the mock examination test. Now, what are the similarities or differences between the non-parametric and the parametric test? The attraction of non-parametric statistics is their utility for small samples, because they do not make any assumptions about how normal, even, and regular the distributions or scores will be. Furthermore, computation of statistics for non-parametric tests is less complicated than that for parametric tests. Non-parametric tests have the advantage of being tailored to a particular institutional, departmental, and individual circumstances. They offer teachers a valuable opportunity for quick, relevant, and focused feedback on student performance. On the other hand, parametric tests are more powerful than non-parametric tests, because they not only derive from standardized scores, but also enable the researcher to compare subpopulations with the whole population. For example, to compare the results of one school or local education authority with the whole country. For instance, in comparing students' performance in norm referenced or criterion reference tests against a national average score in that same test. In a minute, I'll explain what is meant by norm referenced or criterion reference tests. Parametric tests enable the researcher to use powerful statistics in data processing and to make inferences about the results, because non-parametric tests make no assumptions about the wider population. A different set of statistics is available to the researcher. These can be used in very specific situations, such as one class of students, 1 year group, one style of teaching, one curriculum area, and hence are valuable to teachers. Now look at the term frequently used in testing, and most of the tests are categorized on this criterion, whether they are norm referenced, criterion referenced, and domain reference tests. I'll take them one by one. A norm reference test compares students' achievements relative to other students' achievements. For example, a national test of mathematical performance or a test of intelligence which has been standardized on a large and representative sample of students between the ages of 6 and 16. A criterion reference test does not compare student with student, but rather requires the student to fulfill a given set of criteria, a predefined and absolute standard or outcome. For example, a driving test is usually criterion reference, since to pass it requires the ability to meet certain items. For example, reversing round a corner, undertaking an emergency stop, avoiding a crash, etc. So regardless of how many others have or have not passed the driving test. Similarly, many tests of playing a musical instrument require specified performances, such as the ability to play a particular scale or arpeggio, the ability to play a back fugue without hesitation or technical error. So in this case, it is whether the people have those skills or they don't have. And if they don't have, they would get a lower score, and if they have the excellent performance, they would get the higher grade. But within the group, it would be decided by their skills and abilities, and they will not be compared with other students, that how they have been good as compared to the whole class or a group of people. So if all the people fulfill that criterion or the set of criterion, they will all pass, and any of them doesn't meet would fail. Or if all of them don't meet the criterion, they would all fail. So if the student meets the criteria, then he or she passes the examination. If they don't, they would fail. So that is called a criterion reference test. Okay, now we move on to a little bit more on the criterion reference test. A criterion reference test provides the researcher with information about exactly what a student has learned, what he or she can do, whereas a norm reference test can only provide the researcher with information on how well one student has achieved in comparison with another, enabling rank orderings of performance and achievement to be constructed. Hence, a major feature of the norm reference test is its ability to discriminate between students and their achievements. Some are good, others are bad, or some are not so good. A well-constructed norm reference test enables differences in achievement to be measured acutely, that is, to provide variability or a great range of scores. For a criterion reference test, this is less of a problem. The intention here is to indicate whether students have achieved a set of given criteria, regardless of how many others might or might not have achieved them. Hence, variability or range is less important here. More recently, an outgrowth of criterion reference testing has seen the rise of another kind of test, and that is called domain reference test. In domain reference tests, a considerable significance is given to the careful and detailed specification of the content of the domain which will be assessed. The domain is the particular field or area of the subject that is being tested. For example, light in science, two-part counterpoint in music, parts of speech in English language. The domain is set out very clearly and very fully, such that the full depth and breadth of the content are established. Test items are then selected from this very full field with careful attention to sampling procedures so that representativeness of the wider field is ensured in the test items. The students' achievements on that test are computed to yield a proportion of the maximum score possible, and this in turn is used as an index of the proportion of the overall domain that he or she has grasped. So, for example, if a domain has 1,000 items and the test has 50 items, and the student scores 30 marks from the possible 50, then it is inferred that he or she has grasped 60%. 30 divided by 50 multiplied by 100 of the domain of 1,000 items. This was about three types of tests. That was about norm reference test, criterion reference test, and domain reference test. Now let's move on to other criterion of the test, and that is whether they are commercially produced tests or they are the researcher produced tests. There is a battery of tests in the public domain which cover a vast range of topics, and that can be used for evaluative purposes. References were given in the beginning. Most schools will have used published tests at one time or another. So there are several attractions to using published published tests. And what are they? They are objective. They have been piloted and refined. They have been standardized across a named population. For example, a region of the country, the whole country, a particular age group, or various age groups, so that they represent a wide population. They declare how reliable and valid they are, because they can be mentioned in the statistical details which are usually contained in the manual of the instructions for administering the test. Commercially produced tests tend to be parametric tests, hence enabling sophisticated statistics to be calculated. They come complete with instructions for administration, how to administer or conduct them. They are often straightforward and quick to administer and easy to mark. Guides to the interpretation of the data are usually included in the manual with them. Researchers are spared the task of having to devise, pilot, and refine their own test. On the other hand, Howitt and Kramer 2005 suggests that commercially produced tests are expensive to purchase and administer. They are often targeted to special rather than to general populations, for example in psychological testing, and they may not be exactly suited to the purpose required. Furthermore, several commercially produced tests have restricted release or restricted availability. Hence, the researcher might have to register with a particular association or be given clearance to use the test or have copies of it. For example, Harcourt Assessment and McGraw-Hill publishers not only hold the rights to a worldwide battery of tests of all kinds, but also require registration before releasing tests. In this example, Harcourt Assessment also has different levels of clearance, so that certain parties or researchers may not be eligible to have a test released to them because they do not fulfill particular criterion for eligibility. So published tests by definition are not tailored to institutional or local contexts or needs. Indeed, their claim to objectivity is made on the grounds that they are deliberately supra-institutional. The researcher wishing to use published tests must be certain that the purposes, objectives, and content of the published tests match the purposes, objectives, and content of the evaluation. For example, a published diagnostic test might not fit the needs of the evaluation to have an achievement test. A test of achievement might not have the predictive quality that the researcher seeks in an aptitude test. A published reading test might not address the areas of reading that the researcher is wishing to cover. A verbal reading test written in English might contain language that is difficult for a student whose first language is not English. So the golden rule for deciding to use a published test is that it must demonstrate fitness for purpose. If If it fails to demonstrate this, then tests will have to be devised by the researcher. And if that is the case, then the homemade or the researcher produced tests, the attraction for this type of is that such a homegrown test will be tailored to the local and institutional context very tightly. That is, that the purposes, objectives, and content of the test will be deliberately fitted to the specific needs of the researcher in a specific given context. In discussing fitness for purpose, Kronbach and Gronlund and Lin 1990 set out a range of criteria against which a commercially produced test can be evaluated for its suitability for specific research purposes. Against these advantages, of course, there are several important considerations in devising a homegrown test. Not only might it be time consuming to devise, pilot, refine, and then administer the test, but also because much of it will probably non-parametric, there will be a more limited range of statistics that may be applied to the data than in the case of parametric tests. So the scope of tests and testing is far-reaching. No areas of educational activity are untouched by them. There are achievement tests, largely summative in nature, measure achieved performance in a given content area. Aptitude tests are intended to predict capability, achievement potential, learning potential, and future achievements. However, the assumption that these two constructs, achievement and aptitude, achievement and aptitude, are separate has to be questioned. Indeed, it is often the case that a test of aptitude for, say, geography at a particular age or stage will be measured by using an achievement test at that age or stage. Cunningham 1988 has suggested that an achievement test might include more straightforward measures of basic skills, whereas aptitude tests might put these in combination, for example, combining reasoning and particular knowledge. Thus, achievement and aptitude tests differ according to what they are testing. Not only do the tests differ according to what they measure, but also, since both can be used predictively, they differ according to what they might be able to predict. For example, because an achievement test is more specific and often tied to a specific content area, it will be useful as a predictor of future performance in that content area, but will be largely unable to predict future performance out of that content area. An aptitude test tends to test more generalized abilities, for example, aspects of intelligence, skills and abilities that are common to several areas of knowledge or curricula. Hence, it is able to be used as a more generalized predictor of achievement. Achievement tests are more linked to school experiences, whereas aptitude tests encompass out-of-school learning and wider experiences and abilities. Okay, now let's look at how a test is constructed, or how to design or make or construct a test. In devising a test, the researcher should consider the following points. Number one, the purposes of the test. For answering evaluation questions and ensuring that it tests what it is supposed to be testing, validity. For example, the achievement of the objectives of a piece of the curriculum. The type of test, whether it would be for diagnostic, achievement, aptitude, criterion reference, or a norm reference. Second point, which the researcher should keep in mind or consider, the objectives of the test. Cast in very specific terms so that the content of the test items can be seen to relate to specific objectives of a program or curriculum. And number three, the content of the test. What is being tested and what the test items are. The construction of the test involving item analysis in order to clarify the item discriminality and item difficulty of the test. Number four, the format of the test, its layout, instructions, method of working and of completion. Oral instruction to clarify what student will need to write, or a written set of instructions to introduce a practical piece of work, and the nature of the piloting of the test. The validity and reliability of the test, the provision of a manual of instructions for the administration, marking, and data treatment of the test. This is particularly important if the test is not to be administered by the researcher, or if the test is to be administered by several different people, so that reliability is ensured by having a standard procedure which everybody follows. So in planning a test, the researcher can proceed in this way. Number one, identify the purposes of the test. Number two, identify the test specifications. Identify the test specifications. Number three, select the contents of the test. Number four, consider the form of the test. Number five, write the test item. Number six, consider the layout of the test. Number seven, consider the timing of the test. And number eight, plan the scoring of the test. Let's take them one by one. Identify the purposes of the test. Number one, the purposes of a test are several. For example, to diagnose a student's strengths, weaknesses, and difficulties, to measure achievement, to measure aptitude and potential, to identify readiness for a program. Gronlund and Lin in 1990 termed this placement testing, placed in different disciplines. And in different ability groups, and it is usually in a form of pre-test. Placement test is a kind of pre-test, normally designed to discover whether students have the essential prerequisites to begin a program. For example, in terms of they have the knowledge, the skills, the understandings required for that particular course. These types of tests occur at different stages, placement tests. For example, the placement test is conducted prior to the commencement of a program or a course and will identify starting abilities and achievements, the initial or entry abilities in a student. If the placement test is designed to assign students to tracks, sets, or teaching groups, that is to place them into administrative or teaching groupings, then the entry test might be criterion reference or norm reference. If it is designed to measure detailed starting points such as knowledge, abilities and skills, then the test might be more criterion reference, as it requires a high level of detail. It has its equivalent in baseline assessment and is an important feature if one is to measure the value added component of teaching and learning. One can only assess how much a set of educational experiences has added value to the student if one knows that student's starting point and starting abilities and achievements. Formative testing. Formative testing is undertaken during a program. Placement testing was before starting the program. As compared to that one, formative testing is undertaken during a program and is designed to monitor students' progress during that program, to measure achievement of sections of the program and to diagnose strengths and weaknesses. It is typically criterion referenced. Diagnostic testing is an in-depth test to discover particular strengths, weaknesses and difficulties that a student is experiencing and is designed to expose causes and specific areas of weakness or strength. Clearly, this type of test is criterion reference. Then, summative testing. It is the test given at the end of the program to sum up. Summative testing. It is designed to measure achievement, outcomes, or mastery. This might be criterion referenced or norm referenced, depending to some extent on the use to which the results will be put. For example, to award certificates or grades to identify achievement of specific objectives. Now we move on to identify the test specifications. So which program objectives and student learning outcomes will be addressed in the test? And that is at the researcher need to consider what are the specifications of the course and what course content would be included or covered in the test. So number one, Which content areas will be addressed in the test? The relative weightings, balance and coverage of items, number 2. Number 3, the total number of items in the test. How many items will be included in the test? Number 4, the number of questions required to address a particular element of a program or learning. And number 5, outcomes, the exact items in the test. Outcomes, the exact items in the test. Number 6, to ensure validity in a test, it is essential to ensure that the objectives of the test are fairly addressed in the test items. And number 7, objectives should be specific and be expressed with an appropriate degree of precision, represent intended learning outcomes, identify the actual and observable behavior that will demonstrate achievement, include an active verb, be unitary, only one, focusing on one item per objective. So one way of ensuring that the objectives are fairly addressed in test items can be done through a matrix frame that indicates the coverage of content areas, the coverage of objectives of the program, and the relative weighting of the items on the test. Such a matrix is set out in the following, taking the example from a secondary school history syllabus. The matrix indicates, this is a matrix of our test items. So this matrix indicates the main areas of the program to be covered in the test, that is content areas. Then it indicates which objectives or detailed content areas will be covered. Look at this. The content areas here, aspects of the Second World War, and objective area of program content 1A, 1B, 1C, objective area of program content 2A, 2B and 2C, and objective area program content 3A, 3B and 3C in the horizontal line. And vertical in columns you have the content areas. First is aspects of Second World War and the build up to the Second World War, the invasion of Poland, the invasion of France, the Allied invasion, the end of the conflict, and total. Sorry, they are a bit misplaced. The numbers are not exactly in front of the content areas. Just to give you an idea how to prepare a matrix and divide what will be the content areas, what objectives would be achieved, and how much weightage would be given to them. So the matrix indicates the main areas of the program to be covered in the test, that is its content area. Then it indicates which objectives or detailed content areas will be covered, which are I've just shown you from 1A to 3C. These numbers refer to the identified specifications in the syllabus. Then it indicates the marks, percentages to be awarded for each area, and that is shown in this matrix table. Say number 1, aspect of the Second World War, total its weightage would be 10, and the built up to the Second World War its weightage is 20, and the invasion, what is 20, and invasion of France takes the most, that is 35, and the Allied Invasion 25. The matrix indicates several points. Okay, what are these points? The least emphasis is given to the build-up to and end of the war, which carries just 10 marks each in the total column. The greatest emphasis is given to the invasion of France, that is 35 marks in the total column. And there is fairly even coverage of the objectives specified. The figures in the total row only vary from 9 to 13. And the greatest coverage is given to objectives 2A and 3A, and least coverage is given to objective 1C. Let's have a look. 1C. Yeah, that is just 9 in total. Some content areas are not covered in the test items. The blanks in the matrix can be given. Hence, we have here a test scheme that indicates relative weightings, coverage of objectives and content, and the relation between these two latter elements. Having undertaken the test specifications, the researcher should have achieved clarity on the exact test items that test certain aspects of achievement of objectives, programs, contents, the coverage and balance of coverage of the test items, and the relative weightings of the test items. So compiling elements of test items to find the content area, identify key concepts and principles, practical skills, evaluative skills, recording results, and the total. Here, the test is subject to item analysis. Select the content of the test. The test is subject to item analysis, and Gronlund and Lin 1990 suggests that an item analysis will need to consider the following: the suitability of the format of each item for the learning objective. The suitability, number one, the suitability of the format of each item for the learning objective, appropriateness, the ability of each item to enable students to demonstrate their performance of the learning objectives, its relevance. Number three, the clarity of the task for each item. Number four, the straightforwardness of the task, the straightforwardness of the task. Number five, the unambiguity of the outcome of each item, and agreement on what that outcome should be, the cultural fairness of each item. Number six, the independence of each item, that is where the influence of other items of the test is minimal, and where successful completion of one item is not dependent on successful completion of another. And number seven, the adequacy of coverage of each objective by the items of the test. Number eight, in moving to test construction, the researcher will need to consider how each element to be tested will be operationalized, what indicators and kinds of evidence of achievement of the objective will be required, what indicators of high, moderate, and low achievement there will be, what will the students be doing when they are working on each element of the test. What the outcome of the test will be. For example, a written response, a tick in a box of multiple choice items, an essay, a diagram, a computation. Indeed, the task group on assessment and testing, 1988, in the United Kingdom, suggests that attention will have to be given to the presentation, operation, and response modes of a test. How the task will be introduced? Oral, for example, oral, written, pictorial, computer, or practical demonstration. What the students will be doing when they are working on the test. For example, mental computation, practical work, oral work, or written work. What the outcome will be, how they will show achievement and present the outcomes. For example, choosing one item from a multiple choice question, writing a short response, open-ended writing, oral, practical outcome, and computer output. Operationalizing a test from objectives can proceed by different stages. And number one, identify the objectives, outcomes, elements to be covered. Number two, break down the objectives, outcomes, elements into constituent components of elements. And number three, select the components that will feature in the test, such that, if possible, they will represent the larger field, that is, domain referencing if required. Recast the components in terms of specific, practical, observable behaviors, activities, and practices that fairly represent and cover that component. Specify the kinds of data required to provide information on the achievement of the criteria. Specify the success criteria, performance indicators in practical terms, working out marks and grades to be awarded, and how weightings will be addressed, what weightage to each item will be given. And then write each item of the test. And after that, conduct a pilot to refine the language, readability, and presentation of the items, to gauge item discriminability, item difficulty, and destructors in case of multiple choice questions, and to address validity and reliability. The contents of the test will also need to take account of the notion of fitness for purpose. For example, in the types of test items, here the researcher will need to consider whether the kinds of data to demonstrate ability, understanding, and achievement will be best demonstrated in, for example, an open essay, a factual and heavily directed essay, short answer questions, divergent thinking items, completion items, multiple choice items with one correct answer or more than one correct answer, matching pairs of items or statements, inserting missing words. Incomplete sentences are incomplete, unlabeled diagrams, true, false statements, open-ended questions where students are given guidance on how much to write, 300 words, a sentence, a paragraph, closed questions. These items can test recall, knowledge, comprehension, application, analysis, synthesis, and evaluation. That is different order of thinking. These take their rationale from Bloom 1956, Bloom's educational taxonomy. They refer to on hierarchies of thinking, from low order, which include comprehension and application, through middle order, which include middle order thinking, which includes analysis and synthesis, to a higher order thinking, that is evaluation, judgment, and criticism. Clearly, the selection of the form of the test item will be based on the principle of gaining the maximum amount of information in the most economical way. This is evidenced in the use of machine scoreable multiple choice completion tests, where optical mark readers and scanners can enter and process large-scale data rapidly. In considering the contents of a test, the test writer must also consider the scale for some kinds of tests. Further, the selection of the items needs to be considered in order to have the highest reliability. Let's say that we have 10 items that measure students' negative examination stress. Each item is intended to measure stress. For example, item number 1, loss of sleep at examination time. Number 2, anxiety at examination time. Item number 3, irritability at examination time. Number 4, depression at examination time. Number 5, tearfulness at examination time. 6, unwillingness to do household chores at examination time. And 7, mood swings at examination time. Increased consumption of coffee at examination time. 9, positive attitude and cheerfulness at examination time. And number 10, eager anticipation of the examination. You run a reliability test of internal consistency and find strong intercorrelations between items 1 and 5, for example around 0.85. Negative correlations between items 9 and 10, positive attitude and eager anticipation. And all the other items minus 0.79, and a very low intercorrelations between item 6 and 8, and all the others, for example 0.26. Item to total correlations, one kind of item analysis in which the item in question is correlated with the sum of the other items, vary here. What do? You can retain items 1 to 5. For items 9 and 10 you can reverse the scoring. And for items 6 and 8, you can consider excluding them from the test as they appear to be measuring something else. Such item analysis is designed to include items that measure the construct and to exclude items that do not. Well, that was for today. We started with using tests as a research tool and how the researcher can use tests to collect data for the research project. We discussed a number of issues related with tests, different types of tests, different ways of constructing tests, and different purposes of the test, and what type of items could be included in the test. So that was part 1 of using tests. We'll continue with this topic in the next session, in the second part. Well, up to that time, goodbye and thank you very much for listening. Allah Hafiz.